So, yeah, let's make Pong. Let's do the thing. Let's finally bring together all that stuff that we've been talking about and create the game itself in Python. So we're going to need, right? We have a bouncing ball. We have that. That is useful for Pong, right? We have a paddle that moves up and down. That is also useful for Pong. Now we just have to hook them together. Once we do that, we have a game, which is pretty cool. So another gift for you, a gift for you is this is going to be your last programming assignment, what I'm going to do today. You're going to just recreate it. You're getting the video, so I'm not going to give you the code. You'll have to watch the video again to do it in full. Or if you want to do it on hard mode, you can just try it yourself. But you're going to recreate Pong, and that will be your last programming assignment. You cannot get a low score on it if you just do what I do. Okay? So that is my winter break gift for you. But yeah, let's start with Pong. Let's do it. So there's a lot of things. Let's bring in the stuff that we have from last time. I need to make a new file that is nowhere near things that you can see. I'm gonna open up idle, and I will get ready with some stuff. Let's see here. Let's maybe start with the bouncing ball program. Let's move this over here. And I need a new file eventually. And let's copy into this maybe our bouncing ball program from last time. Because we need that one, and then also the paddle movement program. So we're going to start with this one, though. Yeah. Yeah. So if you'd like to follow along, you can go to the code from class link. I'm using the 2D bounce file. And then I'm also going to open the paddle.py file. So I'm going to save this copy of the 2D bounce, though, as we'll call it just pong.py. But I'm just going to save this on my desktop or something, somewhere where you can't get it. You'll have to make it yourself. Pong.py. So this is just the 2D bouncing program from last time. Make the turtle the square, go to a random location, and then start bouncing. So there's that. And so that's that program. And we also have the paddle movement program, paddle.py here. That we will also have to incorporate. So if I run that, remember what that was. That was make the turtle the paddle this time, put him over there, let him move up and down. And then don't let him go too far. Right, we're going to stop that with the go up and go down functions that get called on those key presses, all that fun stuff we have to worry about. But that's the paddle part. So we have those two programs, and essentially they just need to be hooked together. So let's talk about all this. So yeah, we dealt with the paddle already. We figured out how to make it not go outside of the bounds of the window. So we had to do some calculations there, whereas let me try and draw this the best I can here. So what did we do that time? Let's try and remember. So we made our paddle and we stretched the turtle, and we found that he had a height of 120 units in turtle land. And so we had to worry about when is he going to go too far up? Like if we move him up, how do we come up with that 140? So remember, we want the turtle to stop when he's right here. And when is he just right there? So this is y equals 200. But the turtle is relative to where his center line is. And so really you got to go down half. So that's half of his height is 60. Half of 120 is 60. And so that makes y equal 140 here. We don't want the turtle's y to go bigger than 140. If it ever does, bring it right back down to exactly 140. That's as far as you get to go up, Mr. Turtle. Mr. Turtle Paddle, I guess. So that's how we did that. And then you have a similar game that you play for the y equals negative 200 down here. That was going to give us negative 140. Don't ever go less than that. All right, so that's what's going on there. And so we used some if statements to see if we hit the walls and just not go any farther. And then, yeah. Now we need to combine these programs. We want the ball bouncing and then also the paddle moving up and down. But how did we do both of those programs? We made the turtle the paddle, right? And then we also made the turtle the ball. There's only one turtle, right? here's the secret. You can have multiple turtles in your program. We haven't done that before, but you can do it. All right. So there's a concept of the default turtle. That's what you get when you say turtle.goto, turtle.forward, all that stuff. But you can make your own turtle. So these functions, when you say turtle.something, that moves the default turtle. You can make extra turtles for yourself as variables, just with any name you want. And so here's how you make a brand new variable that is a turtle. You call the turtle.capital function. Apparently that births a new turtle, and you can set that equal to a variable, and now you can say like paddle.forward, paddle.left, paddle.right, paddle.goto, and that will affect a brand new turtle with its own shape, with its own stretchingness, and all that fun stuff. So we can make it look exactly as before. You just got to remember to say like paddle.stuff rather than turtle.stuff everywhere once you do this kind of thing. All right, so we're going to do that with the ball as well. We'll make a ball turtle and a paddle turtle, and they will coexist. Okay? So that's going to be the goal. So let's get started with that. Let's make separate turtles and try and bring together these two programs. All right, so let's take what I had first. I called it pong.py. This is the 2D bounce program. And instead of saying turtle.stuff, is the default turtle, right? We want to make a ball turtle. All right, make the turtle the square, make the turtle the ball, I guess. Let's say that. So make a turtle for the ball. So we're going to make a variable. We're going to say turtle.turtle and set that equal to a brand new variable. So we'll say ball equals turtle.turtle. Something like that. Okay? Make the turtle the ball. This is a brand new turtle. Now we say ball.blank to move this turtle. All right? So that's what's going on there. We can use the default turtle still to draw the rectangle. That's the turtle.up, turtle.goto. That's still fine. But once we get past that, we need multiple turtles on our screen. So we want a ball turtle and a paddle turtle. All right, so this ball turtle, we want it to be a square. So instead of turtle.shape, it's ball.shape, ball.fill color, ball.turtle size, and it's ball width. We should probably say that, right? So let's just say ball everywhere. And it's balls X, balls Y, because we're going to have a paddle too, right? Ball X offset, ball Y offset, all this stuff. It's affecting the ball. We need multiple of these. Can't just be one turtle anymore. Okay? Ball X offset. So this is going to be, it's going to take a second. Change all these variables around. But that's what you got to do. And then we got to put the ball in the correct starting location. Ball.up. Ball.goto, wherever it needs to be. And it's balls X, balls Y initially. Is that making sense? Then we bounce if hit wall, moving balls X and balls Y and balls X offset, all that fun stuff. So this is just we have to move all this around. And hopefully it makes sense. These are just new names. They're not going to change the program at all. But it's going to make it easier to have multiple turtles so that we know which one's talking about which. Because it's not just one single turtle anymore. So this is a bit time-consuming, but necessary. Because we're going to have ball X, ball Y, ball X offset, whatever, and then paddle X, paddle Y. It'll make more sense when we make these name changes. And I will definitely be forgetting one of these, so we're going to watch the program end early and yell at us when I do. Please shout out if you see me miss a turtle. Turtle X equals ball X plus ball X offset. We're moving the ball's Y based on its old Y coordinate plus the ball's Y offset. Okay, the paddle can have its own stuff. The bounce fit wall, that's fine. And then finally, redraw the turtle. It's not turtle.goto. We're not moving the default turtle anymore. We're moving our ball turtle that we set into this variable up here. Whee! So, there's a lot going on, but it's mostly just name changes right now. Okay? So I believe we will see if I messed up. I think that was every turtle. The draw rectangle is fine. That's the default turtle still. That can be a turtle. It's okay. But from here onward, we want to say ball everywhere. Let's look it over one more time. There we go. Yeah, I missed some. There's ball X offset, ball Y offset. Any others? Ball up, ball go to. I believe that's looking good. All right, let's try running this. This should still be our 2D bounce program. We've just changed the names, and we also, technically we have two turtles on the screen. One that drew the rectangle, the default one, and then one that functions as the ball. So there's the default turtle, shaped like a turtle, drawn that. And then there's the ball turtle, and it looks like, let's let it hit every wall and make sure I'm not messing anything up. It looks like that's still working. But you see how there's two turtles right now. Isn't that cute? You got the original one that drew the bounds of the window and then stopped doing anything because we didn't tell it to do anything else. And then the new turtle is the square, functioning as the ball. So we can keep this default turtle there, or we could hide it. There's a way to do that. Let me show you that. So there are a lot of considerations to make now. So Python turtle. And there's a way to hide the turtle. I think it's just turtle.hide turtle if you want to hide the default one. So we don't need it after it draws the screen. Wow. Everybody must be programming Pong today. The documentation doesn't want to load. I'm pretty sure it's turtle.hide turtle, but we will confirm that. Dun, dun, dun. And then we're going to bring in the paddle after we get this working. Wow, this web page is really slow. Let's try it again. Well, if this doesn't work, I'll try like an archived version of it or something. This is silly. Does all my internet not work? I guess so. All right. Okay, now it's happy. Just had to try something else. So hide. Yeah, it's hide turtle, turtle.hide turtle, or turtle.ht, either one. So that will hide the turtle if we don't want him in the top left there. So this will hide the default turtle if I do this. Turtle.hide turtle. So now he won't be in the top left. After he draws the rectangle, he will hide. There, he went away. And then the ball just takes over. That's the only visible turtle now. We make him here, and then set him in the right way, set the color and all that fun stuff, and then make a bunch of variables involving the ball. It's ball.goto now. Okay, so that was mostly just a lot of name changes. Are there any questions about that? Is that good enough? So we made a brand new turtle, and it will function as the ball. And then we want to take our paddle program and somehow incorporate that too. So I want to like copy and paste it somewhere. Somewhere before this loop down here, pretty much. So let's kind of section off this program. Let's have ball part of the program and then paddle part of the program. So this can be like paddle stuff. We'll do it this way. And then we can make a ball stuff section as well. Make it all pretty. So after here, we'll do paddle stuff. We'll copy and paste it in there. And then we'll do ball stuff below. That makes sense to me. So now I'm going to try and copy and paste everything new into this paddle part. So we already drew the rectangle. That's fine. That was up here already. That was just something in common. But what's the new stuff? It was make the turtle the paddle and then like have the turtle listen for key presses and stuff. So I'm going to copy all of that, all the rest, down into here. Okay? So that's what I'm going to take from the paddle program. And let's see what I need to say about that. Let's see. So now this is, we're going to make a turtle for the paddle. Not make the turtle a paddle, but make a turtle for the ball. Maybe I should say that. Make a turtle for the ball, and then we'll make a turtle for the paddle. And so to do that, we're going to say paddle equals, and then to make a brand new turtle, you say turtle dot capital turtle. That creates one on the fly, like it gets born on that line. It's a brand new turtle for the paddle, just like we made one new one for the ball. And so now, if we want to move this turtle, now we say paddle dot blank everywhere. Everyone we would like to mess with that one. That's pretty nice. Now let's change those variables. All right. So we'll say paddle.shape is square, paddle.fill color, that can be purple again, paddle.turtle size, and we already used paddle X and paddle Y, that's good. And then it's paddle.up, paddle.goto, all that fun stuff. Okay. So paddle.goto, not the default one, paddle.goto. And then one thing we can do, I think I wrote it here, is the default turtle can still like be invisible and listen for the key presses. That's fine. I don't have to make the paddle do that job. That's okay. It's okay to keep these lines right here because this is just the default turtle. Needs to, you can have that one listen. Some turtle somewhere needs to listen for key presses, and the default one is fine with that. We don't have to say paddle dot stuff here. If we did that, actually, it would change things, and so that would make it a bit more complicated. So let's keep it like this. The default turtle listens for the key presses, but when those functions get called, it's manipulating the paddle turtle. We're saying paddle.goto everywhere. Okay, so that's fine. They're sharing the work. That's okay. And then, yeah, I think that is a good start. Let's see if both of these programs coexist. So the first thing that's going to happen is we're going to draw that rectangle, hide the turtle, hide the default turtle, make the paddle hook everything up for that, and then start the ball off in the random place moving around. Okay, so let's see if those pieces, those three pieces of this same program can coexist in a normal way. Kind of. The interesting thing is this paddle is sideways right now. Everything else works. The reason it's sideways is because of the way we did things from before. So we were using the default turtle. Let's see if I can explain this. We were using the default turtle to draw this window, and then we immediately changed it into the paddle. And the default turtle was facing upwards once it was done. It came upwards. And then we moved it down to here and stretched it in the weird ways and made it the paddle. So the default turtle, or the new turtle, this paddle turtle, every turtle when it begins its life faces east, and so that's why it's facing in a weird direction right now. We actually stretched it in the weird, in maybe the wrong way. So your options are as following. You could stretch it 6 1.5, that would work, or you can tell the paddle to rotate. Okay, so either one would be happy. So let's do it this way. Maybe paddle dot left. Just turn it 90 degrees, something like that. That would make sense. Or maybe let's make it face, yeah. It'll make it face upwards. We didn't need to worry about that before, but now we do. It's kind of funny. So now it's happy. Now it's facing in the right way to be stretched on those axes, and it all makes sense. So this goes up and down. This is fine, and the ball is moving straight up and down randomly, it seems. But all of these programs in one big program, they seem to be happy. So draw the window, make the paddle, set up the key presses, and then move the ball. So we got all that working, which is pretty nice. The only issue right now is, of course, the ball and the paddle are not interacting. That's going to be the hard part. Another fun thing about turtle graphics, this is a harder problem to solve, but if you hold in keys, it makes the ball move slower. Whee! So if I'm holding in the down arrow, see how the ball gets a bit slower there? That's just a quirk in the way that the key pressing is working. But that's okay. So yeah, any questions about this so far? We got the paddle part, we got the ball part, they are coexisting. We have multiple turtles now, a turtle for the paddle, a turtle for the ball. They are happy and separate. We just need to make them talk to each other, essentially. We need to know when the ball bounces off that paddle. Okay? So that's the goal. Maybe another thing that we can do is make the ball move a little bit faster. So let's do that. So right now, the length of the hypotenuse of the direction arrow is 1. We can make it 2 by multiplying both of these by 2. That'll make it move double as fast, and maybe that's more interesting of a game. The ball's moving faster. Whee! Maybe that's better. Now it's harder to play. Whee! But you can always make it move slower by holding in keys. That's a funny thing. Okay, so that's that. It seems to be working. Let's hook the ball and the paddle up together now. So, what do we want to do? I think there's one more thing I wanted to do. Just to make the game, like, not immediately end, right? It would be unfair, wouldn't it? I think we had to deal with this in Scratch, too. It would be very unfair if... I guess I can use this one. It would be really unfair if the ball started its life right here, right? And then with an initial direction of right there, you'd immediately lose the game, wouldn't you? So to keep that from happening, because that's one thing that, the ball starts its life at a random location with a random direction. To keep this from happening and having like the user punch their screen, what we should do is probably start the ball somewhere on the right half of the screen so that there's time to actually move the paddle and get the ball the first time. So like put the ball somewhere over here. You can still have a random direction of that way or that way. It doesn't matter. But at least you have time to like move the paddle down. Okay, so let's do that. So let's start the ball on the right half of the screen. So make sure that like the ball could be up here, the y coordinate could be up here, down here, but the x coordinate, don't let it go negative because this is 0, 0 right here. If we just don't let the x coordinate go negative, then it will start on the right half. So let's do this. Ball's x initially between 0 and 150, all right? So that's the right half. Does that make sense? So now, no matter what, randomly, the ball will be somewhere over here, even if it's coming straight at the paddle. So that's a bit of an easier game to play, I think, now. It's not super hard mode, at least initially. So that's better. Like, there's time. There's time to get that now. All right, so that was just a quick change. That's not horrible. What else? And let's see. Okay, yeah, let's have losing before we worry about the paddle too. So if you lose the game, right? You lose the game if the ball hits this left wall. And we actually have an if statement for that. So let's hook into that because we want to kind of stop the game once the ball hits the left wall. That means the user lost. The player lost. So I forget a closing parenthesis. Sorry. So if the ball ever hits the left wall, let's say that that's game over. And so let's make like a variable that represents whether or not the game's over because that we want to stop moving the ball once that happens, right? So let's do this. If the game is not over, we want to like move the ball. But if it is over, we want to stop. So let's change while true to like while the game is not over. So initially, I don't know where I want to put this. Let's see. Let's put it right here. So is game over? At the start of the game, that is not true, right? The game is not over yet. So we're going to use this variable to keep track of whether the game is over. Okay. So initially, the game has not been lost. So that's fine. And we want to continue playing the game, continue drawing new frames, moving the ball, while the game is not over. Okay. So while it's not true that is game over. Does that make sense? Or while is game over is false. So while it's not the case that the game is over. While not is game over. Does that make enough sense? So while not is game over, it's kind of out of order, but hopefully you can read that. So while the game's not over, then we want to keep moving this ball. Draw the new frame. And so the name of the game is, we want to notice that the game is over and set it to true eventually. See that? And that will stop everything. I'll stop that loop. So let's find the code where the ball hits the left wall. Where is that? It looks like it's probably in this bounce if hit wall function, right? So this was hitting the bottom wall. This is the top wall. There's the right wall. And here's the left wall. If we ever hit the left wall, we lose the game now. It's not just bounce off of it anymore. Does that make sense? So if we ever try to go outside, move it back inside, of course, that's fine. But then we don't change the x offset to move in a different direction. We don't care about that anymore. The game is over. Okay? Stop the game. Stop the game. So this is game over. So we're going to stop the game now by saying is game over equals true, because that's the variable that's watching for that. So if we set that, then that's going to stop this loop and the game will end. Or the ball's going to stop moving, essentially. And so we're going to set this inside of a function. We have to play that game of saying global when we do something like that. Just remind Python this is a global variable. We want to be able to set it. This is not a local variable we're trying to talk about right now. We want to change this exact variable right here. So if we ever hit the left wall, set is game over to true, and that will make this loop stop, because while not is game over, so when it's false, not false becomes true and it runs the loop. But when is game over becomes true, not true is false, and that will stop the loop. That makes sense. Okay? That's what's going on there. And so now if I run this, and I let the ball hit the left wall, if I lose the game, look, isn't that beautiful? So I can still move the paddle, that's still hooked up, but the ball won't move anymore because we set is game over to true, and so not true becomes false. And while only does the loop while its condition is true. So we just stopped. Does that make enough sense? Any questions about that logic? It's a little complicated, but that's what you put in a video game. So I think really the last piece of the puzzle now is to have the game end, or not have the game end, but to have the game continue and not end when the ball hits the paddle. Because right now it's just the ball is gonna like morph through the paddle. Just walk through walls and hit the left wall no matter what. So we'd like to hook these up together so that we can actually play the game properly. Because right now, even if I'm dead on, it'll just go through it and stop the game. So we want to bounce off the paddle too. Okay, that's really the last piece of the puzzle, and it is the more complicated part, I would say. So we want the ball to bounce off the right side of the paddle if we ever get there. And so let's make a function for that, because that makes one part of our job easy, right? Because what do we want to do every frame? We want to like move the ball a little bit, bounce off any wall if we need to, and then also bounce off the paddle. If we hit the paddle, bounce off. See how, if we had a function like that, how easy it would make this implementation right here for draw frame. So if we did that, that would be fine. But then we have to worry about this. But just pretend you have it. It makes some of the implementation nice. Now you just have to go off and figure out what this means. Okay, so that's what we need. So let's get ready for it. Def bounce if hit paddle. And so this is going to take care of noticing did we hit the paddle. If we did, move the ball, bounce it off. Okay, so that is this is now what we need to figure out. And so this is going to take some thought. All right, so we need to worry about sizes of things. So here's my best drawing of the paddle zoomed in on it. So we have like it's relative to its center. It knows where it is relative to its center, and it is width 30 and height 120. Yeah. And then the ball itself, like if it hits here's the ball hitting the paddle just so slightly, right? The ball is size 40 by 40. And it's also, it knows where it is relative to its center. So it's the ball is hitting the paddle essentially when it's this close, right? You see that distance? When it's that close. Because it's relative, all those distances are relative to their centers, which is a little weird. So we'll have to worry about that. So, okay. We know this is true, but like the ball hits the paddle when they're this close, but we also have to worry about where, like this is distance in the x direction, right? But we also have to worry about distance in the y direction, because sure, this ball is totally hitting the paddle, but we also want the ball to not hit the paddle when it's down here. Do you see how the x distance is still the same, but the y distance is way off? So that's the other piece of the puzzle. You have to worry about both of those. So, all right, where is the lowest point where we want this ball to hit the paddle? We could make we have some options here. Like we could say that this is the lowest point where the ball hits the paddle, but that would be a little unfair, I would say. I think most games for Pong, they let you hit the ball just if you ever so slightly touch it. So right there, that would be the lowest point where the ball hits the paddle. Yeah. Likewise, up here would be the highest possible point where the ball would hit the paddle. So that would be the range. Any higher than that, like it goes through and hits the wall and you lose the game. Any lower than that, it goes through, hits the wall, you lose the game. Okay, so that's the name of the game right now. Let's see what else. Yeah, so we gotta do that, and then we have to come up with an if statement. Like, when is it true that the ball is like between here and here? Does that make sense? And it's also just close enough to hit the paddle as well. So we need a distance in the y direction and the x direction. Okay. So this, what are our variables right now? How do we know where things are? We have paddle x and paddle y to know where the paddle is, and we have ball x and ball y to know where the ball is. Okay, so those are the coordinates we know about, and we're going to have to use those. So here, wherever that is, we know that it's at paddle x and paddle y. And this ball, wherever it is, we know that it's at ball x, ball y. Let's see, yeah. There. So we know that. And now we have to compare using those things, all right? So the idea is the ball, we have to come up with our if statement. The ball touches the paddle when? When a lot of things are true at once, actually. So, all right. So we need a few things. We need them to be really close, right? Really close in the x direction, not any farther away than this amount, yeah? What is that amount? So that is, let's see here. This, what's their distance? It's how far away are their centers in the x direction? What is that distance right there? Well, it's going to be half of the paddle's width, that's 15, plus half of the ball's width, which is 20. This is not really drawn to scale. So that, you see that? You add those up, and then you get where the ball touches. That's what we want to have. That's what we're measuring right there. That amount, that's 35, okay? So, all right. If the ball is this far away or any closer, like it went inside the paddle almost even, if it's this far away or any closer in the x direction, then it might be hitting the paddle, right? So, when all right, so here's the ball's x, right? When it is at least, right? When it is, I guess when it's equal to, it's exactly hitting the paddle, when it's equal to the paddle's x plus 15 plus 20. Does that make sense? Wherever the paddle's x is right now, that's here, plus 15 plus 20. If that's equal to the ball's x, they're grazing each other. We have hit. So equals paddle x plus half of the paddle plus half of the ball. That's how it would know. That's that distance. So wherever this is, plus 15 plus 20, if that is equal to where the ball is right now, then they have just touched each other. Okay? So that's that. And then also, just by the way that we're moving stuff, it might move a little bit more than that every frame. It might be over here. That might be where the ball is, and it's even closer. We're not ever going to draw it like that, though, but it might be, in terms of the variables, even closer than that. So if it's ever equal or smaller than that, okay, if it's ever less than or equal, then the ball and the paddle are close enough to maybe be touching each other. But you don't know, once you do this comparison, if the ball is way down here or not. Because the x's are fine, but the y's are way off. You see that? So we need another comparison to see, are we okay within the up and down range too? Okay? So, okay. Now, the ball is touching the paddle maybe when this is true, but definitely if the ball is between, right? The y for the ball is between here, because that would be the center of the highest point that it could touch the paddle. It's between here and here. So that's kind of the goal. If the y for the ball is anywhere within this range, and also the x's are close enough like this, that's when it hits. You see, that all has to be true at the same time. That's the goal. So now I have to come up with some comparisons for the y's as well. So, when do we know that the ball is between, it's not any higher than this. What is this width, right? Or what is this height? How do you get up all the way up to here from the center of the paddle? That would be like from, I don't know how to say this, between like here and here. That's like this width, from the center of the paddle to the center of the highest ball that could be touching it up there. What is that amount? Because that's one thing we check for, all right? So the ball's y, it better be less than or equal to, like this is the highest point, it better be less than or equal to the paddle's y, because that's given you right here, plus half of the paddle's height, yeah, that's 60, plus half of the ball's height, that's 20 again. So that, the ball's y could not be any bigger than that. Any bigger than it would be going outside of the range that the paddle could hit. Okay, so the ball's y better be less than or equal to however high this is. That's the paddle's y plus half the paddle's width plus half the ball's width. That would get you up to that tippy top point right there. Less than or equal to paddle y. Let's see. Paddle y plus 60, that's half the paddle, plus 20, that's half the ball. Does that make sense? So if that's true, that means that the ball is somewhere between, like it's definitely less than here. It's from here downwards. And we also want to rain it off down here as well. If we have both of those at the same time, we know it's within the right range. So let's do the same thing for the ball better be bigger, like the y better be bigger than this. You see that? Because that's the lowest point that it would hit the paddle. So what is this distance? What's from here, the center of the paddle, to the center of the lowest ball that could be hitting that paddle? That would be the ball's y better be greater than or equal to this time, right? This is the lowest point. It better be bigger than this. Better be greater than or equal to the paddle's y minus 60 minus 20. You see that? Half the height again. We're going in the negative y direction. Minus 60. Bring it down. Minus another 20 to bring it down to there, wherever this is. Better be greater than or equal to whatever that is. This is paddle y minus 60 minus 20. Because this is paddle y. That's that center point. Minus 60 gets you to the bottom part of the paddle. We want to accept hits even lower than that, minus half the ball's length as well. That would give us this y coordinate. And we want the y coordinate of the ball to be bigger than that. You see that? So if it's bigger than that, and then also smaller than that, it's within the range in the y direction. You see that? That's what's going on. That's what's reining it in the y direction. I think that was everything I wanted to write. So that's the lower one, and this is the upper one. The ball's y better be less than or equal to this one, which is equal to the paddle's y plus half the paddle plus half the ball. Okay? That's going to keep it in the y direction, and then the x direction was this one again. Maybe it makes more sense now that I've done the others. The ball's x better be, right? Here's the ball's x. It better be less than or equal to this spot right here. And how do we get that spot from the paddle? It's, all right, here's the paddle's x plus half the paddle plus half the ball. That gives us here. It better be less than that or equal to. That means we're grazing the paddle. Does that make enough sense? So I think that's every calculation we need to do. So all of these three things need to be true at once for the ball to be hitting the paddle. Okay? Are there any questions about that? That's a bit of a complicated condition. That is what it means. It's between, that's how we know it's between here and here in the y direction and like here and here in the x direction. That's what it means to hit the paddle. Got two dimensions. So there's that. So it's like thing A, thing B, and thing C all have to be true at the same time. Okay? So that's going to be our bounce off paddle. Finally. So bounce of hit paddle, we need to check, right? We need to check all these things at once. The ball touches the paddle when. Let's just do both of these. A is this, right? A is if the ball's x is less than or equal to paddle x plus 15 plus 20. B is equal to when the ball's y is less than or equal to paddle y plus 60 plus 20. And then C is equal to ball's y greater than or equal to paddle y minus 60 minus 20. So all those things need to be true at once if the ball hit the paddle. So if A is true, and B is true, and C is true, then we bounce off. Okay. All three conditions are met. Now we want to bounce off. And how do we do that? That's the last piece of the puzzle. It's essentially the same as hitting the left wall. We got rid of that condition over here. We're going to change an offset. Okay. So when we hit the paddle, it's just the same as hitting the left wall. Like the ball was coming in. Say that this is not the left wall, but it's like the right side of the paddle now. If we were coming in with this direction, we want to bounce off with this direction. Boop. So that was a something offset in the X, something offset in the Y. What changes? We were coming in the X to the left, and then down with the Y for this particular example. We want to bounce off, still down in the Y, but now going right instead of left. So that's the X offset. The X offset is flipping when we hit a sidewall. Okay, and the paddle is just a fancy sidewall. So we'll be messing with that now. That's what we change. So we're flipping the X offset when we hit the side. Okay? Bounce off by changing the, what's it called? By flipping the X offset for the ball. And then also we want to bring it back in, because just if it's less than or greater than or any of these, we want to like bring it back into exactly there. And so we also want to deal with that. So let me, if it's any less than, we want it to be equal to. So let's set all these back into what they need to be. If we tried to go inside, like we either, remember all these conditions, it was either like we either hit the right wall or we were trying to go past it, okay? If we tried to go past the paddle, like rein it back in, move it back inside. Move it to just touching the paddle. So that was like, if this was any less than what it should have been, like make it exactly equal to. Boop. That's the idea. And it was only for the X direction that matters. And then we deal with flipping the X offset. So we're going to move off to the right now by flipping the X offset. Make it negative whatever, negated version of whatever it used to be. It was coming into the left, so it most likely was negative. And now it's going to come off positive. But same Y offset, that doesn't matter. Okay? And so now, because I'm changing the ball's X and the ball's X offset, I have to mark those as global for this function. I guess I don't really need the Y's. But that should do it. Yeah, does that make enough sense? We'll try this in just a second. But we discovered what it means to hit the paddle. Or these conditions, if those are all true at once, either we're hitting the paddle or we're trying to like go inside of it a little bit. So like move the X back, move the X coordinate back to where it's just exactly hitting the paddle, if we ever try to go past that. And then shoot off the ball in the opposite direction now. This is going to move it the other way. And then it won't go towards the wall and like end the game. Now it's not going to go through the paddle anymore. Notice when it hits the right side of it. Okay? That's the idea. So now our game is every frame we move the ball a little bit, and then like we're moving the paddle, of course, with our up and down arrows. That's dealt with by all this. But the ball is moving on its own in its current direction, whatever that happens to be. If it hits a wall that is not the left wall, we're going to bounce off. If it hits the left wall, we stop the game. We do that now, right? It's like the is game over variable. And then if we hit the paddle, we can't hit both the ball and the paddle at the same time usually, but or at least the left wall and the paddle. That will never happen. So bounce if hit paddle as well, because maybe like in the same frame, like the ball is, I don't know, maybe the paddle's right here and the ball is also right here, so it's hitting the top ball and the paddle at the same time. That's fine. It just can't go through the paddle anymore. So do both of those separate, both of those checks, and then we have a new location for the ball by that time, and then also we have a new direction for the ball too if we ever bounced off of anything. So that's what needs to happen and be checked every single frame. Move the ball a little bit, see if it touched anything important, and bounce it off if it did. Does that make enough sense? There's a lot going on there. So let's try this. Let's see if this code is doing it right. there's definitely the opportunity for bugs to be made. Let's try it. Whee, there's the ball. Let's see if it hits the paddle. Oh, yeah. Let's make sure it'll hit just the top part only. Whoop. Yeah, there it goes. Oh, it's so satisfying. And so we've got room there. And appears to be doing the right thing, bouncing off in the correct direction. It's keeping the same Y offset. So like here, it's about to hit the paddle and move up. It's still moving up as it moves out, but it's moving right and out rather than left anymore, because that would go through the paddle at that point. So it's the X offset that needed to be flipped. And we're doing that. And yeah, we're just noticing when it hits it and bouncing it off. That's all of this. That's this new part. That's all that right there. It's beautiful. And then if it ever hits the sidewall, we have our range. We're making sure like the Y is within this range if it hits the paddle. Who cares if it was close enough in the X? If it's far away like this, it's still not us. It's still not the paddle. It was the wall instead. And so that is that's dealt with by this check in the bounce if hit wall function. That will stop the game if we ever hit that sidewall there. Okay. So I believe that is it. Are there any questions about this game? Any pieces of it? Does that make enough sense? It's so cool. I'm glad you get to, like, I'm forcing you to type it all out. So this is going to be hopefully a good learning experience. But let's try and walk through what's going on. Let's play it one last time. So initially we draw this rectangle for the game board. And then we hide that turtle that drew that game board. And then we hook up the paddle to go like up and down, left and right. That's fine. Make a new turtle for the paddle. Change its shape to be what it needs to be, like stretch it in the proper dimensions, all that fun stuff. And then set the up and down function so that like when we press down, we really are going to hit the paddle. Whee! All that fun stuff. And up goes up as well. Making sure not to go any farther, because if I keep pressing down, I don't want to go even farther outside these bounds. That's what this if statement is taking care of. And so that's the paddle stuff. And then the ball starts out its life at a random location, random direction, all that fun stuff. Make a new turtle for it, stretch it, and we're going to use all these variables to keep track of where it is, how it's moving. That's the offsets, right? Making sure that it's going to move at a similar speed every time we restart the game. That's dealing with the length of the hypotenuse of the direction arrow. It's kind of cool. We have to worry about whether or not the game's over, so we have to keep a variable to worry about that. And then, yeah, we're not ever making marks with our turtles that are paddles and balls, so we pick them up and move them to where they belong to begin with. And then, yeah, the ball's code is pretty much draw frame. It's forever, while the game's not over yet, just draw a new frame, and draw frame has the bulk of the work. It's like, all right, move the ball in its current direction by some amount, so we know how to do that. And then if we ever hit a wall, bounce off of that. If we ever hit the paddle, bounce off of that. Two things to worry about. That might update the ball's X and ball's Y inside of here. And then finally, after both of those are done and have had a chance to redirect the ball and its direction and its location, change its direction and its location, then actually go to that new thing that we've decided on. Go to the new coordinates for the ball that we have picked. Okay? And then the details are, of course, in the bounce if hit wall. Like if it's too low in the Y direction, then bounce the ball off the bottom wall. If it's too high in the Y direction, bounce it off the top wall. We used to bounce off the left wall, but now we make sure that stops the game. So now we set this game over there. For the right wall, we move the turtle back inside as we always do, but it's the X offset that's flipping now. The X is getting too big, and we bounce off the right wall. And then the paddle is very similar. It's just a lot of things at once. It's like we need to be within this weird range of X's and Y's to be close enough to the paddle to actually be hitting it. We need all of these things to be true at once, we noticed. Lots of variables involved. But if all of those are true at once, then we're hitting the paddle. Make sure we're exactly grazing it so that we draw it in a clean way. And we don't like hit it twice after a couple frames. That would be weird. And then make sure we're moving off in the opposite direction so that we don't like hit the ball twice in like 2 consecutive frames. That's what we're doing. So that bounces us off in the correct direction. It's just like a sidewall. Here's the right wall. It's the same thing. Bouncing off a sidewall means flipping your X offset. And yeah, after both of those have had a chance to manipulate the ball's coordinates and direction, we have a new thing to draw to our screen. It's draw frame's job to take care of them. Okay? So all of those pieces slowly but surely working together. Computer is very fast. This is a lot of lines, but it's running very, very quickly. It's given us a game that we can play, which is really fun. Yeah. I think that's all that I wanted to say about that. Any questions about any of that? And so you know how to make the game faster, right? You can change this these hypotenuses, multiply by 5 if you want the ball to move really, really fast or something. You know how to stretch the ball and the paddle in different amounts. You'd have to change your checks, though, if you did that. You can change the color of these things. You can make it your own. Make the ball a square, or make the ball a circle rather than a square if you wanted to. Totally fine. But yeah, I think you know all of those pieces now. And so that's pretty cool. Yeah, so there's your code. I will not be giving this to you. Any questions about it, though? Yeah, I'm recording it right now. Just like every other lecture. So that's what you'll be using. So, yeah, that leads us right on into your programming assignment. This is your last programming assignment of the semester. So here it is, programming assignment number 9. So here's what you're doing. You're going to do Pong. Implement Pong in Python using my steps. Whatever I did today, you do it too. You're, of course, allowed to change the game, give it more features, like have it keep score if you want to learn how to like type text to the turtle screen. That's totally fine. Change the colors of stuff if you want to. Make it your own, but at a minimum, do what I did. And yeah, upload a video of the program running. And I don't want you to just blindly follow what I did. So please try to explain the code back to me as I just explained it to you. I want you to understand it a little bit at least. Ask me questions if you have questions so that you can explain it properly. All right. Yeah. Give me like, I don't know, a minute. Show me it working. Walk me through the code. Show me that you understand what's going on. And that is your last programming assignment. I think that's all I wanted to say. That's going to be due probably the last week of classes, right? So the 30th. So, yeah, it'll be due on the 30th. So you got a little over a week to do it. And that is your final programming assignment. Any questions about any of that? You mean like the score? Oh, yeah, that's a good question. Like, let's see here. The turtle library should have text. Whee! Dun, dun, text input. Should be text output. Dun, dun, dun. Python turtle draw text, something like that. I think it's turtle.write. Is that here? Yeah, more drawing control. Right. So the turtle can write text to a certain coordinate using turtle.write. You give it, let's see. You can move the turtle to somewhere, and then you give it text to write out. If move is true, but yeah, you'll have to search for it. Like here's an example. Dun, dun, dun. So like if you put the turtle somewhere, and you say turtle.write, give it some string, it will draw that string. So that's something that you can do. And then to keep track of your score, I guess you would have to count every time you hit the paddle, right? So you have to like keep a variable here. If you ever got in here, like that was a new point, maybe. Something like that. Does that make sense? Yeah, so that's something you could do, but just search for it. I think there's going to be plenty of tutorials about that. Sure. Any other questions? All right. Yeah, I think that's everything that I wanted to say, so I will stop the recording.